Okay, so when you're actually doing this course, you can just go to the YouTube and then just review this. So again, talking about linear graph, y equals mx plus b, dependent, slope, independent, and the y-intercept. What does y-intercept mean? Y-intercept graphically means where any line, like linear line, touches the y-intercept, okay? But this is not only limited to the linear line though. Eventually, you're gonna do some other functions. You see this x? This will become x squared in grade 10. This is called a parabola, okay? It looks something like this. Notice even this one, it goes through the y-axis, right? This is still the y-intercept. So the y-intercept for any function, for any graph, is where it touches the y-axis, okay? For a linear one, it doesn't have to go up. If it's going up, this means the slope is positive, right? Rise over run is a positive number. So like 3 over 1, you go 3 up and 1 down. But what happens sometimes is that instead of going up, the slope is negative. Now think of an example in real life where the slope would be negative. I'll give you one, okay? Let's say the dependent variable, or sorry, the independent variable, yeah, is the video game hours or the Netflix hours that a student watches, okay? That's the dependent variable, and that's the independent, sorry, x is independent, and the dependent variable would be his exam scores. You see, the more someone plays games or watches Netflix, the lower his grades would be. Okay, this is an example of a negative slope. Can you think of one more example where a slope might be negative? And I'll give you one more, okay? Like how often they smoke or drink. How often they smoke or drink, or number of cigarettes per week, number of alcohol per week, and their lifespan. You see, the more they do those things, the lower their lifespan. See that? This would also be an example of a negative slope. Try to think of one by yourself. Something that would have a negative slope. There's an infinite number of these examples.
Would temperature work?
Okay, temperature as the independent? Temperature and what?
Like maybe the seasons would be independent and then the temperature.
Yeah, that could work, yeah. So you can have the months, right? And then the temperature, yeah. Because it's gonna go down like that, right? Yeah, that'll be an example. Now, how do we graph a linear function? So let's say y equals 3x plus 3. We did a couple of these yesterday. Do you remember how we graphed it?
You put a point at 3.
Yeah, so let's make the slope 4 so that we were not confused. Yeah, so 1, 2, 3, that's the y-intercept. And now where's the next point?
Four spots after 3.
Say that again, sorry?
4 spots after 3.
So up or down?
Up.
Up, yeah. So right there at 7?
You move one space to the right.
Yeah, exactly, right? Now, why do we do this one space? This is not the point, yeah? We have to go one space because when you look at the slope is 4, but there's an invisible 1 at the bottom, right? And what is slope? Slope is rise over run. So you need to go 4 units up and 1 units right. And there we go. That's a linear, and then you just join it, and then you extend it on both directions. You just need 2 points to make a linear graph. This is called graphing using the slope and the intercept, okay? But you could do this another way by making a table of values. And again, you just need 2. When x is 0, what is y? In this equation, if x were to be 0, what would the y value be? So you have 4 times 0, yeah? Plus 3. What is this equals to?
7?
No, 4 times 0
just
is
3.
just 3. Right? There we go, 0, 3. You see, notice that was our first point here anyways. Okay, and another point. When x is 1, what's y? So you just do 4 times 1 plus 3. What does that equals to?
So 7.
7, right? So there we go. You see both these points are both these points, and then you can just graph them. 0, 3 is this point, 1, 7 is that point, okay? This is doing it by a table of values.
Okay.
What if the slope were to be negative? Now what do we do? Actually, let's make this like that. Now notice the slope is negative, so instead of our graph going up, it's gonna go like down this way. How do we go about sketching this?
I'm guessing you start at 3.
Yeah, you do. You start off at 3, and then what do you do?
You go down 4 spots.
Yeah, good. So if you go 4 spots down from 3, where do you land?
-1.
Yeah, good. And then what do you do? So right now we're here.
You go 3 spots to the right.
Yeah, good, perfect. So 1, 2, 3. So right there, you see that's our second point. And then you just join them, okay, like that. Now this is again doing it by the slope and intercept. Again, table of values works just as well. Again, look at this. When x is 0, what's y? It'll be 3. You don't even have to do any math because by definition, y-intercept is when x is 0. You see that? Algebraically, it's going to be -4/3 times a 0 plus 3. And this entire thing is 0. Anything times 0 is a 0. So plus 3, you just have a 3. Okay? When now, no one likes decimals or fractions, okay? So you don't put a 1 here. If you put a 1 here, you would get -4/3 plus 3, and then you would get -1/3. That's not a very nice point to plot. So what we're going to do is instead of putting 1 for this specific question, we want to kill the denominator. You see 3 in the denominator? So I'm going to put x as 3. Okay, why did I do that? Because now the denominators cancel out completely. See this? So what would that be equals to? So when you cancel the numerator with the denominator, right? You just get a -4 times 1 plus 3. That's what that is. Or they just completely cancels out. So you get -4 plus 3.
So
what is that?
-1.
Yeah, -1, and that's the point that we have here. Okay?
Okay.
So this is doing it by either table of values or graphically. Graphing is easier, like a slope-intercept is easier. Let's move on. Let's do some questions from the book. Again, the idea behind linear is very simple. It's like it's harder when they give you like word problems. Here, let's look at this. So this lady has a lawn mowing job. She wants to earn $910. So she wants to earn $910 in total, okay? And then what else is going on? How is she gonna make this money? She's gonna rent out, yeah? Or she's gonna mow lawns for $15 an hour. Okay. $15 an hour, she's gonna mow lawns. She needs to make $910. What are her upfront costs?
She has to pay 100 for gasoline.
Yeah. So you see that's gonna add up to the total money, right? Here, plus 100. And what else? So she has to actually earn $1,010, right? What about the lawn, this thing?
She also has to pay for that.
She also has to pay for that, right? So we're gonna add this here. So that'll be 1230. Okay. She needs to earn $1,230 at $15 an hour. So how many hours is she gonna have to work for? So we're gonna turn this into an equation. Okay. On the right side, we have 1230. What do we have on the left side? So here, right, X represents the number of hours she's worked for, okay? Number of hours she's worked for. And Y represents her salary. So if her wage is $15 an hour, yeah? How do we write this as an equation? Y would be what? Her salary would be, in terms of X, 15X, okay? $15 an hour. If she works for 2 hours, she's gonna make $30, right? So there we go. Y would be 30 when X is 2. Now what's the question asking us? The question is asking us, when the Y is 1230, what is the X value? See that? Like that. There we go. That's our equation. How do we solve this equation?
Instead of multiplying, you divide.
Yeah, exactly. You divide both sides by 15. So this cancels out. So you have 1230 over 15. And I'm gonna grab a calculator here. 1230 divided by 15. So the answer is 82. So X is 82. So she'd have to work 82 hours to afford all this. Okay? So again, the equation is very simple. The math here is very simple. The hard part is coming up with translating the words into like a mathematical equation. That's the harder part. The more problems you do, right, eventually you'll be able to like see it. Like it's not gonna be as hard. Here, let's try doing another one. So this guy opened a bank account. He deposited the same amount of money each week for 2 weeks, okay? So let's say in week 1, he deposited what? X. We don't know what that is, yeah? What's the question asking us? The question is asking us how much did he deposit each week? So whatever they're asking us, that'll be X, the unknown, okay? So week 1, he deposited X. Week 2, he again deposited X. So how much did he deposit in total? In terms of X?
2x.
2x, right? And then this is the total amount of money in his bank account after 2 weeks. What did he do? He used a bank card to buy a gift. So do we add 14 or subtract 14?
Subtract.
Subtract 14. Now what will this be equals to? It'll be equal to the remaining balance. And what is that? It's in the question.
107.
107, there we go. So again, it's not that hard, but again, the math here is gonna be very easy. It's this part that's a little bit difficult. So now let's solve this equation for X.
Instead of subtracting, you'd add 14.
Yeah, you would add 14 on both sides. Why? Because it completely cancels out here, and 104 plus 14 is 121. Now what?
Now you divide by 2.
Yeah, exactly. And then 121 divided by 2 is 60.5, and that's the answer. So he deposited $60.50 each week for 2 weeks. Okay. Okay, I mean, these ones are pretty simple. Write an equation for each situation, then solve your equation. Again, remember, whatever's missing, whatever's the unknown, whatever we're looking for is x.
Okay.
So look at a number is being multiplied. So our number, the unknown number is gonna be x. It's multiplied by 6 and the result is 48. So what is the equation?
6x equals 48.
Yeah, perfect. 6x equals 48. Now how do we solve this?
You just divide by 6.
Yeah, so 48 divided by 6 is 8, and that's our number. Well, let's look at B. When the number is doubled, again, our number is x, is doubled and 10 is subtracted, the result is 37.
2x minus 10 equals 37.
Yeah, exactly. 2x minus 10 equals 37. 2x is gonna be, now how do we solve this actually?
You would add 10.
And then?
And then you would divide by 2.
Yeah, and there we go, easy. 23.5 is our number. Let's look at C. A number is multiplied by 7. So what does that mean?
7x.
Yeah, and then 2.5 is added.
Plus 2.5.
Yeah, and what will that be equals to?
58.5.
Boom, bada boom. All right, now how do we solve this?
You subtract 2.5.
Yeah, you subtract, so 56, and then you would divide, right? Because it's being multiplied, you want to divide both sides to get rid of the 7, and then 56 divided by 7 is 8, and that's our number. Easy enough? All right, see if you can do this. A grocery store collects different cans. The cans are packed in boxes that hold 24 cans. The store has collected 744 cans. Part A says graph this situation. Again, the equation is pretty simple. What would the equation be here? We're looking for the number of boxes.
(24x equals 744).
Yeah, so that's our equation, right? But that's not the answer to part A. That's the answer to part C. 24x equals 744. So how do we graph this? And remember, it's a linear thing, right? It's a linear equation, yeah? What is our x and what is our y? If you think about this situation, what is our x and what is our y? What do they represent? What's the independent variable? What's the dependent variable? No? The independent variable is the number of boxes. Okay, what is the dependent variable? What is 744?
The cans.
Yeah, so the dependent variable is the number of cans. Now it's asking us to graph this, right? It's number of boxes on the horizontal. See, it was right here as well. The answer was right here. Horizontal is always the independent variable, so number of boxes. Vertical is always the dependent number of cans. okay? And we've done this before. Graphing this might be a little bit difficult because you have to go all the way to 744. What we can do is this. We can make a table of values. If there's one box, how many cans are there?
24.
Yeah. If there's two boxes, how many cans are there? 48, right?
Mm-hmm.
What I'm gonna do is I'm gonna do 10 and 20 because we need to go all the way to 744. So I'm just gonna add zeros for all these, beside all these numbers, okay?
Mm-hmm.
Does it make sense? Well, I'm just plugging 10 and 20 in here, like in here.
Mm-hmm.
So now we're gonna graph this. So we need to go up until 700 something, right? So we'll just go up by 50 each time. I think that'll be fine. So this is 10, 11, 12, 13, 14. And then here we can just go by what? 5, I guess we can go by. So 5, 10, 15, 20, 25, 30. And see, there's no point going by 1 because the number of cans will be like, what, 30 something?
Mm-hmm.
Just by looking at this equation. So if you go by 1, you're gonna run out of space. So that's my independent variable, the number of boxes. Here I'm gonna put dependent variable, and again, you don't go up by 1 each time because you have to go all the way to 744. I'm gonna go by 50 each time, okay? And the smaller your scale, the more precise your graph is. The bigger your scale, like for example, if we went by 500, 1000, the graph won't be very precise for answers, okay? So that's 300, that's 500, 550, 600, 650, 700, 750, 800. So far, so good. You understand the scales?
Uh-huh.
So now what are our points? Our first point is 10 and 240, right? So we're just gonna graph it here. 10 and 240 is gonna be just a little bit under 250, somewhere there, okay?
Mm-hmm.
The next is 20 and 480. So I know this is 450. So 480 will be somewhere in the middle of 450, a little bit higher than the middle, because right in the middle is gonna be 475. So 20 and a little bit higher than 475 right there. You see that?
Uh-huh.
And that's our curve. Okay?
Mm-hmm.
And that's the answer to part A. Part B, use your graph to estimate the number of boxes needed to hold 744 cans. So we're trying to solve this equation graphically.
I'm guessing you would draw a line by 744.
Yeah, all right, let's do that. So where would 744 be?
Right below 750.
Yeah. And now what?
You make a line going down.
Yeah, exactly. So what's the answer?
30.
Yeah, so it's approximately 30, right? It's about 30 because it's not very precise. Because again, algebraically would be the more precise way. Graphically, it's not that precise. So our answer to part B is approximately 30 or about 30. And it says estimate, that's why. Okay, that's fine. You're not going to be precise with this. But we can be precise with this though. So C is, we have this equation, 24x equals 744. D says solve. How do you solve this equation?
You just divide by 24.
Yeah. So 744 divided by 24 is 31. There we go. And that's the precise answer. X is 31. Compare a solution in part D with B. So compare these two solutions. Do you think your solution is correct? Explain.
It's close.
Yeah. So are you happy with it? Yeah, that's good enough, right? That's correct. It seems correct. Oh, do you want me to throw a curveball at you? All right, let's do this. The sum of three consecutive whole numbers is 36. Determine the numbers. Well, the answer is 11, 12, 13, right? 20, yeah. Is it? 24 plus... Oh, we'll find the precise answer. Yeah, it's 11, 12, 13. So you can just guess and check that, right? But how would you actually solve this? We need to show our steps. Again, remember, whatever is missing is always x. So what does consecutive whole numbers mean? It means like this, 7, 8, 9, 1, 2, 3, one after another. Now, if I told you the smallest number out of the three for us is x, okay? What's the next number in terms of x?
Y.
No. It's going to be in terms of x. What do we do to 7 to get 8?
You just add 1.
Yeah, so in terms of x, what would that be?
1.
X plus 1.
Oh, okay.
Okay, now what would be the next number in terms of x?
X plus 2.
Yeah, there we go. So those are our three numbers in terms of x. And it says the sum of all these is 36. So what's our equation?
Just like add the top part, then you get that answer.
So you would add what? In terms of x, you would add all three of these, okay? You'd add x plus 1 plus x plus 2 equals 36. Now, how do we solve this equation? We have to clean this up. Are there any like terms on the left side?
Yes.
Okay, so add them up. What do we get? So you have x, and x. Those are the like terms. And then you have, in terms of numbers, you have 1 and 2.
So you have 3x plus 3?
Yeah, exactly. 3x plus 3 equals 36. Now, what do we do to solve this equation?
You subtract 3.
Yeah, you subtract 3, right? So 3x equals 33, and then you divide by 3 because it's being multiplied here. You do the opposite, which is division. So there we go, x is 11. So our first number is 11. Our next number is x plus 1, 11 plus 1, 12, right? And the third number is x plus 2, so 11 plus 2, 13. There we go. Okay? That's how you do it algebraically. Now, what about this? What if I throw another curveball? Instead of saying 3 consecutive whole numbers, what if I told you 3 consecutive even numbers is 36? So what does that mean? It means 6, 8, 10. Okay, something like that. That's not the answer, but consecutive even numbers, that's what it means. Now, if our smallest even number is x, what is the next number in this in terms of x? What did we do to 6 to get 8?
Add 2.
Add 2, right? So what's the next number here in terms of x?
X plus 2.
Yeah. What's the next number here in terms of x?
X plus 4.
There we go. Okay. And now, what will be the equation?
3x plus 6.
Yeah, there we go. So 3x is 30, right? Subtract 6 from both sides. And then you divide by 3 on both sides. So x is 10. So that means our smallest number is 10. So that means our numbers are 10, 12, and 14, and that does add up to 36. and we're done.
Mm-hmm.
That makes sense?
Uh-huh.
Okay. So he has a number of counters. He places them in 3 different bags. And these are all equal, okay?
Mm-hmm.
You read the question. How can you determine the number of counters in each bag? So what is our unknown? Our unknown is the number of counters in each bag, right?
Uh-huh.
That's what we're trying to find. So what will that be? That'll be X.
Mm-hmm.
Cool?
Yep.
And now, what else do we know? So he's put X in all 3 bags, and now he has 2 left over, okay?
Mm-hmm.
He has 2 left over. So how many did he have in total in terms of X?
$17.
No. Oh, actually, yeah, that's right. You're right. So the total number is 17, okay?
Mm-hmm.
But in terms of X, okay, notice he has 2 left over, right? What goes on the left-hand side of this equation? You need to use this information and this information. What is equals to 17? The total number of counters, but how can you represent that with X? Here, there's X in each 3 of these bags, right?
Mm-hmm.
So how many total in these 3 bags?
3x.
And how many do we have left over?
2.
2, there we go. That's our equation. Do you see it?
Yep.
So the total is equals to the number of here. So the answer is gonna be 5. But again, the hard part is the equation. The math is very simple. So there's 5 in each bag, and then there's 2 left over. 15 plus 2 is 17.
Okay.
What about this?
You just add 3 and then divide 4.
Yeah, so the answer is 7. Okay, 28 over 4 is 7. Super simple. All right, why don't you read this, and I need you to tell me the equation. Read this and give me the equation for this.
Well, the answer to of the equation would be 2 to the 3.7,
Yeah.
after the equal sign.
Yeah, so that's the answer. What does the X represent? It's right here. Whatever they're asking, whatever's missing is always X.
The mass in each bag.
Yeah, now if you think about it, what's the mass in the first bag in terms of X?
Just X?
Yeah, second bag is also X, but the third bag is not X. What's the mass of the third bag in terms of X?
It's X minus 4.5.
Yeah, perfect. Okay, now what goes on the left side of this equation?
3X minus 4.5.
Yeah. So how do we solve this? We add 4.5 and we divide by 3, right?
Mm-hmm.
It's 4.5 divided by 3. So what would that be? Again, decimals, you can't really do it in your head. Divided by 3. So the answer is 79.4 grams.
Uh-huh.
Cool?
Yep.
I'm looking for some like real life problems. Here. Tell me the equation. Again, what does X represent? X is the cost of each individual binder.
Mm-hmm. The answer would be $10.
No. She received 10 from the cashier back? No, right? She did not receive $10 back from the...
1.15.
Yeah, the answer is 1.15.
Okay.
This is what she got back. So just think about it. What does X represent? Each binder cost, yeah?
Mm-hmm.
So how much did 3 binders cost?
3X.
3X, right? How much does she have in total?
10.
10. So what goes on this side? We subtract something from something. If you had $10, okay, you bought 3 binders worth $2 each. How much do you have left?
$2.
4. 10 minus 3 times 2 is 6, right? So that will be 10 minus 6. So you'd have $4 left. Yeah?
Mm-hmm.
So look, so what would be the equation in terms of X? 10 minus, right? What?
3X.
Yeah, there we go. Okay, that was hard. So whenever you see a problem like this, you can always put numbers into it. You see, when you put numbers into it,
Mm-hmm.
it'll make things easier. Now, how do we solve this equation?
You add 10.
No. Why not? Here, I'll show you why not. You add 10 on both sides. The 10s do not cancel out. Instead, you would get 20 minus 3x equals 11.15. That does not help us. Try again. Adding 10 does not help us. It does not kill off the 10 on the left.
So subtracting?
Subtracting what?
the 10.
Yeah, subtracting the 10 helps us because 10 minus 10 is a 0, right?
Mm-hmm.
So you get 0 minus 3x, which is just minus 3x, equals 1.15 minus 10 is, I believe, negative 8.85. Yeah. Now what?
You divide.
You divide by
minus 3.
yes. Why don't you plug that in your calculator? And now remember, on your calculator, you have this button. This is not minus. This is minus. By itself is minus. If you see a minus in a bracket, that means it's this, like negative 3. So here you would want to do negative, yeah? And again, it only already comes in a bracket. This minus sign divided by this minus sign 3. If you do minus here and here, it'll give you like a syntax error. Try it. Tell me what you get.
.33.
No, you did the other way around. Minus 8.85 divided by minus 3. Not 3 divided by 8.85.
.95.
Yeah, that's right. So that's the price of each individual binder. Okay. Again, just be careful when there's like a negative sign. Like here, let me see if there's another one. Let me just speed run this. Okay. The first two are easy. The first one you'd add 2 and then divide by 5. This one you subtract 4.1 on both sides and then you divide by 2. What about C? What do you do in part C?
You add 7.
Yeah.
And then you multiply by 3.
Yeah, good. What about D?
You subtract 0.25.
Yeah.
And then you multiply by 5.
Yeah. What if I throw another curveball at you? 2 over x equals 9. How do you solve for x?
You multiply by 2.
Will that help us though? Yeah, we could try that. 2 times 2, 2 times 2, right? See, these don't cancel out. Instead, you get 4 over x equals 18. It did not cancel out the 2. Multiplying 2 is not right.
Dividing?
Yeah, better yet, I'll show you a technique. It is dividing, okay, but you'll still have the unknown in the denominator. We don't want the unknown in the denominator. Here, in a case like this, we do something called cross multiplication, okay? You have 2 over x. What's the denominator of 9? What is the denominator? 1, right? Let's just think of it as slope. If slope is 9, that means your run is 1. The rise is 9, but the run is 1, okay? So you give denominators. Now you want to cross multiply. We're going to multiply this denominator with this numerator, this denominator with this numerator. What does that give? 2 times 1 is 2, yeah? Go on.
9x.
9x. See, now what do you do? You're going to get rid of the 9. Yeah, and there we go. That's the answer, 2 over 9.
Okay.
Shortcut method. Whenever the unknown is in the denominator, you swap places with this guy. And the answer, you'll get it in one shot. Even for something like this. Even for something like this, okay, see the unknown terms are in the denominator, you swap places with it. And then from there, you do your usual math. Or you cross multiply it. Okay, the 2 ways to attack a question like that. Yeah, read this question. So, and then give me the equation. And again, X is going to represent the cost of 1 kilogram of steak.
So the answer would be 23.19.
Yeah. Again, remember, X is the cost of 1 kilogram of steak.
So 4x
Yeah.
plus 3.79.
Yes, there we go. And from here, the math is very simple, right? What do we do?
Subtract.
Yeah, and then?
Divide.
Yeah, whatever that is on a calculator. Yeah, can't do it in my head. 23.19 minus 3.79 divided by 4. The answer is $4.85. Cool?
Yep.
Yeah, see, again, this is the hard part. Once you have this, the answer's in the bag. Okay, here's this equation.
So 14 plus -2.
So 3n equals 14 plus -2, yeah?
Which is 12.
Yeah, it is.
And then you divide that by 3, which is 4.
Yeah. Or what you could do is this, right? You have a double negative. You can turn that into a +2 in the first step, right? And then again, from here, it's the same. You subtract 2 on both sides, and then you divide by 3. Could have also done that, but what you did is good. That works. So now these are communication problems. It's a little bit annoying. I mean, again, there's no wrong answer to this, as long as you give like a decent example. So what they've done here is they've given you this equation, and the question's asking you to come up with a situation that could be resembled by this equation. You understand the question? You're supposed to come up with like the words, right? Or an example of a scenario, which then we can use this equation to solve. Okay, I'll give you one. I went to the store, right? I bought 3 kilograms of steak plus 1 barbecue sauce, and the total bill was 27. This kind of testing your creativity. So can you come up with one?
Let's say I bought 3 notebooks and the cost would be N.
Yeah.
And then the added tax would be 1.5.
Yeah, good. You should probably bail out of that country though. I mean, I guess not. Because that's 50% tax if you're paying $3 each, right? Yeah, that could work, right? And to solve this is very simple. You just subtract 1.5 divided by 3. Okay? All right, let's do a couple of questions from the chapter self-test. Boom. Use the following graph to solve the equation. So we're trying to solve for 3n plus 7 equals, let me just make this more. Alrighty. You see this question on a test, how would you do it?
You would just draw a line at 52.
Yeah. So if that's 60, where's 52? Here or here? 1 box up or 2 boxes up?
2?
No. See, 50 to 60, that means there's 5 boxes, right? 1, 2, 3, 4, 5. So each box represents 2 units. So 52 is there. And then you pull this down. So the answer is 15. What about this one? So patterns, and they've asked us to come up with an equation for the patterns.
Well, it would be like T1 equals A, and then N minus 1 in brackets, then times B or D.
And what's D?
Like the difference.
Yeah, but what is it? What's the number?
4.
4. And here we can replace the Tn with Y, okay? Y equals 1 plus, which is A. N becomes an X times 4. Now clean up this bracket. Open that bracket.
1 plus 4x.
Yeah.
And then minus 1.
No, not minus 1. Try again. How do you open a bracket? You do this. You do x times 4, okay? Which is 4x, or x4, 4x, same thing. And then you do minus 1 times 4 as well. So what is this? Minus what? Minus 1 times 4. What would that be?
Minus 4.
Yeah. Okay, not minus 1, because you also have to multiply the other element in the bracket with the 4. Now let's clean this up. There's some like terms here.
1 plus minus 4.
Yeah.
Which is minus 3.
And there we go. Okay, this is the right form, mx plus b, right? And what does the x represent? What does the y represent?
The x is like the amount of things in the figure.
No, X is the figure number.
Oh, okay.
What is Y?
The amount?
Yeah. So
Okay.
X here is 1, Y here is 1. X here is 2, Y here is 5, okay?
Okay.
Part C, it's asking us to create an equation, which we already have, to determine the number of figures with 161 counters. Counters are these like red little blocks. So is Y 161 or X 161?
Y.
Yeah, so what's the equation? How is this gonna change? 161 equals 4x minus 3. Yeah? So how do we solve this?
You add 3.
164 equals 4x, and then what?
And then you divide by 4.
Yeah. So the answer is 41. So figure number 41. So what does this mean? This means figure 41, when you keep going, we'll have 164 counters. The red little tiles. Okay? Not bad, right? Once you remember this, the equation is very simple. It's just coming up with the equation is the more difficult bit. All right, I guess we can call it a day here. We'll pick it up next time, okay? And what I'm gonna do is I'm gonna upload this video and you can watch it whenever you want later on in life or in the coming semester. All right. See you later then. Bye-bye.
Bye.